Today we're going to roll the calendar back to 1981. We're going to look at a Panasonic Portapak VCR, one of those big VHS things that you carried around on one shoulder, and a camera that weighed equally as much on the other, just so you could get a few pictures. Oh, the fun of it all. Let's check this one out.
Today we have a vintage VCR in for service. This is an old Panasonic portable VHS machine. This one would go back to, I don't know if there's a date on this thing or not, but it's going to be an early one. Early 80s, I'm going to guess. Let's see here. What does it say on here? Well, it says the Central Trust Company. So the Central Trust Company obviously had this as an asset at some point. No serial number on the bottom of it. You can tell this is an industrial machine, as it features a camera connector. It has audio and video BNC connectors, RCA audio out, and a microphone connector. Because this was designed exclusively pretty much for recording with a camera.
Now you could plug a tuner into that camera connector, but it wasn't like the later models actually had a plug on the back for the tuner. This one here was primarily set up to be used to record on the go from a camera.
Complaint on this one, this was sent in, by the way. Complaint on this one is that it goes in and out of color. Does not play back correctly. One of the nice things about the commercial gear is that they all use the standard power connector. So the power supply for my Sony 3/4 inch VO4800 will work this because it has the standard 4-pin DIN power connector. And for commercial equipment, this was all standardized. Before I even power this thing up, we're going to pull the top off it so we can take a look at the machine itself. Top cover is held in place by a couple of screws in the back. Looks like somebody's been into this too, because when they put it together, they didn't get the shielding in place properly. So we'll proceed to lose all the screws while we take it apart. Oh, one screw's already missing from here. So that's one other good thing about documenting the disassembly, is that you can find out when there's pieces that are missing, screws that are missing and stuff. Be able to document that so that the guy can't say after the fact that I lost a screw, because well, we got video evidence that I didn't lose the screw. It had a screw missing when it came in. Handle flips up, that way it clears the front. On the back here, one more screw will remove the head shield. See, when this was put together the last time, this should have been put underneath there. And there should be another couple screws on the top here that hold this shield in place. So if we identify the components on this old beast, we have the 2-head video drum. This is a single speed machine, so it only records and plays in the SP speed. We have our full track erase head over here. We have a tape stabilizer, both before the full erase, and another tape stabilizer that is located before the audio head. Here's our audio and control track head. This one uses an incandescent bulb for the tape end sensor. That gives you its vintage of this. This is the capstan motor over here. The capstan motor is belt driven to drive the capstan flywheel, and it will also drive the take-up. Probably this one might have a separate motor on it actually. Let's see if it does. Or is it belt driven? No, it's belt driven. You can see the shaft down here turning that drives this drive idler. Hopefully the drive idler isn't a problem, because a drive idler for this thing would be pretty tough to find. Might be available just as the tire, but the whole idler assembly itself would be very difficult to find. Power the unit up, and shows that the battery indicator goes all the way to full, which is a good sign. Goes all the way up to the top. When I power it up, so you can see, you saw the light flash there when I first tried it. When there's a tape inside this thing, I think there's a little button that gets pushed down to tell it that there's a tape in, if I'm not mistaken. Let's just try putting a tape in and see what it does, and I'll hook it up to a monitor. Need a BNC adapter for this one. Got my BNC adapter here. I'll grab my monitor cable, and we'll hook this up to a monitor and see whether we get anything on playback. So video output on the side, audio output. Let's turn on the monitor and get this power supply out of the way. Don't need it. Don't need it up on the bench. Just taking up space. Monitor is on. Stop light is lit up because it has power. We'll first try fast forward and rewind. So fast forward works, that's good. That means that idler is good. As does rewind, that's excellent. One thing I don't have to worry about. Let's load it up. And it goes immediately into stop. The big problem with these units that used visible light, of course, is that any light landing on the photo sensors will cause the unit to shut down. So you gotta keep them dark. One thing I can check to verify whether it is the end sensors is if it'll fast forward, which it will. And when I hit rewind, will it stop when it gets to the end of the tape? Which it does, which means that we don't have a problem with light getting picked up by the sensors when I go into play. So first things first, let's investigate the mode switch. As you can see, the bottom only has 2 screws in it as well. So somebody has obviously been into this unit
and condemned it.
Bottom comes off to reveal a big circuit board. These were a real pain in the butt to work on because of the way that they are designed. You'll see that this is an early type of double-sided board where they use these plated through connectors, and these are the ones that are marked in green here. These were always sources of problems where they would fail on the pass-through between one side of the board and the other. And as you can see, they're underneath the ICs, which makes them really difficult to try and repair if the problem is caused by that. But I want to inspect this board and just see if there's any damage, like around the sides here. You can see these traces here look like they may be in rough shape, and around here. The way these units were designed, they were designed to fold apart with all the major parts just popping out. Like the boards are all interconnected together with these flexible connectors. But you simply popped out some catches and the front panel would open up and drop down. Man, it's been so long since I've worked on one of these machines, I've forgotten how to get into them. Like, I haven't seen one of these machines since the early 80s. There was not very many of these ones sold because they were so inconvenient for people to have to carry around a separate recorder that as soon as the camcorders came out, people just threw these things out. They couldn't get rid of these things fast enough when the camcorders hit the market. So that kind of eliminated me having to work on any of these things. I'm kind of glad that I didn't have to. Okay, should be a couple screws down the bottom here now, and the circuit board should lift out. Or I shouldn't say lift out, should fold away from the chassis. That screw is loose, so someone's been into here, I think. And with this board folded down, this lifts down like this, and we can see into the bottom where the belts and stuff are on here. Oh yes, I gotta undo this connector on the front here. Unplug that one. It's for the tape counter memory. And peer into the bottom for the mode encoder switch, which is a slide switch. You guys probably can't see, but it's right there. We're going to take that switch and we're going to clean that switch because that slide, what they call it, it's a mode encoder, but it's a linear, not a rotary encoder. So first I'm going to mark where it is so that I know to get when I put it back in what position it's going to be in, because if I'm off one way or the other it won't work properly. So we're going to mark this thing with a Sharpie or something, or it might even have a timing mark on here. I can't see it because it's dark, but oh yeah, there's a timing mark. There's a little groove right there. So that's the home position. So I'm going to remove the mode switch, clean the mode switch, and then we'll see if we can get this thing to go into playback mode without it shutting down like it's been doing, because this switch is obviously going to be extremely dirty. See, these are not easy machines to work on just because of the layout. You don't get a lot of room to work on these, but at least you can power these things up. When they're on their side like this, I can power this thing up and work on it. But the biggest problem with these units is this double-sided board, the way it's made with the through connectors, because a lot of them go through under ICs, and if that fails, the only way to fix it is to actually remove the IC and put a piece of wire through it, and you know, it becomes a bit of work to do it. Belts look okay in here. There's got a couple belts. Belts all seem to look okay. I don't see any broken belts. They're not slipping, so that's a good sign, because these belts again would be ones that would be hard to find. This mode switch should just pop apart. I think it's an Alps switch in this thing. It should pop apart, but I don't really have to take it apart. I can spray contact cleaner in through here. There, it might be better for you guys. Not quite as overexposed, but I should be able to get contact cleaner into there. But most of these switches, I can just pop them apart. But the top comes off on most of them. Does it on this one? That's the question. Or is this one? This one looks to be welded shut. So we'll get some contact cleaner in there. In through here. And clean that thing up. And now, thanks to COVID, I have an endless supply of nitrile gloves. To my employer, if they're watching, no, I'm not stealing new gloves. These have all been previously used, and the ones that don't get ripped or damaged at work, I've been, instead of throwing them in the garbage, I've been sanitizing them and bringing them home for reuse a second time. Complete recycling. Because I have to wear gloves at work whenever I have an interaction with a customer. Go into a customer's house and stuff, I have to have my full PPE on, mask, boot covers, and gloves. And a lot of times I'm not even touching anything there, but it's just for safety. So once I'm done, I throw them in a box if they're not damaged. And then which ones aren't damaged, because a lot of them are. A lot of them get tears and rips and stuff in them. Those ones that aren't, I disinfect them, bring them home and disinfect them. And expose them to UV light and disinfect and stuff, and get a second use out of them to protect my hands from chemicals and stuff that I could get from using cleaners. I don't know that Neutral is all that hazardous, but I just don't like the stink it leaves on your skin. It leaves that oily film when you're done. So as well take advantage of some recycled PPE. Here we go. So hopefully that will clean the contacts good enough without having to break the switch apart. Some of these switches you can just pop them apart, they're held together by clips, but this one here they've actually fused the little plastic tabs together, so this is probably the next best thing to doing that. We'll just clean this up and see whether the switch will work now that it's clean. Okay, put the switch back into place. And this end fits underneath. There's a little tab down there. See, I don't want to touch my camera because my gloves are all greasy. But there's a little tab down here that this fits into. Gotta make sure my alignment is correct, because there is room to move the switch up and down a bit before tightening it up. Okay, that switch is back in place. Now we'll just place the chassis back into its, I'll just place the board back into the chassis here just so that I can set it down and test it. Like that. I guess I can lose these now oil covered gloves. I'll blow those up later. You like the sound of firecrackers? Just put your air compressor into the fingers of nitrile gloves and hit them with about 90 psi or more of air, and they go off like a bear banger. Okay, power. Let's see whether this will work any better now. I gotta find the eject switch here. It's there. Where is it? It's here somewhere. There it is. If we watch the unit when I try to power it up, it's still shutting down. Oops. Okay, yeah, that was the right mode. Watch the mode switch, it'll move. But it's shutting down before it even completes the loading cycle. So there's a couple things that can cause that on these units. If the system does not detect that the drum is spinning, either at the right speed or not spinning at all, it'll go into a shutdown because it assumes that perhaps there's dew or something that's causing it to stick. So you'll see that exactly the same thing happens if I hold the drum motor from turning. So it could be that it's not reading the FG signal or the PG signal and detecting it as a drum motor not starting. Of course, these ones didn't have the diagnostics that the newer ones did, so the only way to determine that will be actually to look at the frequency generator and look at the PG signals where it feeds into the servo, which is down here. This is AN, I think this one's the servo, N6350. I see the adjustments for PG in here. I also see record. What's this one say? Record something. But these are the adjustments for a PGB and PGA. And so it might be not detecting that the motor is spinning. A bigger concern though, if we look over here, is the circuit board. See the trace? It's gone green. This trace has been eaten away. And what's happening is these little electrolytic capacitors here are starting to leak. And what they leak is a corrosive fluid that attacks the board. You can see that the board has been attacked here, and the board has been attacked here, and there's some more over here on this other side, over here where the board has been attacked. You see the trace down here, right in here, the trace has been attacked, and again over here, this trace here has been attacked. More than likely, what the problem is that the circuit board itself has been damaged by a leaking electrolytic. And repairing that might make this thing work on the short term, but on the long term, even if I can get this thing to run, I don't think that this is going to last any length of time. So I don't know how much further the guy wants. The guy already spent a small fortune getting this thing to me, and I advised him that before shipping it, that it may very well not be repairable just because of the age of it. When you get these old electronics, people love to save their old electronics, but there comes a time when you really have to wonder why, because with so many things that can go wrong. Here's some more. See, this little cap here is leaked, and this trace is eaten away right there. You can see it. Right, that trace is eaten away, and all it takes is just one little trace to be damaged, and it could cause any number of problems. So I can certainly bridge over the traces that I can see here that may be damaged, and maybe I might get this thing to do something. That's about all I can do right now. It's kind of a shot in the dark. It's obviously shutting down for a reason, and I'm thinking it's because one of the signals that it's looking for is not there. But I see a lot of traces here. There's some more over here. You see right in this area here. There's more damage here from capacitors that are leaking. And to go and replace them all would not be economical. Even though they're through-hole caps, it would not be economical. So, to change all these capacitors, I would have to charge several $100s. And a machine like this just isn't worth it. It's just not worth it to spend the kind of money that it would be required to restore this thing and make it work like it should. And what I'm going to try and do is I'm just going to try and get the thing to play a tape, if possible, because the guy that owns it, I don't know how far he wants to go, but just doing an initial inspection, I can see that there's a fair bit of damage here that needs to be taken care of before this thing's ever going to do anything. So I'm just going to quickly try and repair the traces. This is the audio circuit over here, so I don't think that on the left here, this is the audio circuit here, so I don't think this one's going to have much effect on the system control. But this stuff down here, this is definitely in the servo circuit, you see. And his complaint was it goes in and out of color, and so this area here definitely, I think, might be where the problem is. So I'm going to try and fix this part up here and see whether I can get this thing to do anything more than it's doing. Incidentally, this area here where you see the damage, if I look on the other side of the board here, this is in the circuit that says cylinder free run. So this control here, this is for the cylinder free run control. And it looks like there's a trace right down here that it's completely missing. It looks like it runs under this cap, so it might connect this cap through to the other side of the board. I'm going to have to actually pull this capacitor out to see where that trace goes, and maybe I can get a piece of wire in place of that. And same with this one here. This one here looks like it runs from over here. It looks like it runs over to this through hole, flow through. And basically what this silver, looks like silver paint, well, that's what that is. That's a conductive ink. We can get stuff called Circuit Works, or we could. I don't know if it's available anymore, but it was a silver type ink that you would put down, and you could draw circuits. You could paint a circuit, and when it dried, it was conductive. And that's what they did on these boards. Is before they actually before they developed plated through boards, they just used regular double-sided crappy circuit boards, drilled holes in them, and filled the holes with this conductive paint. And that was what was used to put the signal from one side to the other. And it's a very, very poor way of doing it, in the early days. And this is part of the problem with this design and why these were not really worth repairing because once you start getting into failures of the through connectors and capacitor leaking, damage, where do you stop, right? It just, you fix one thing and something else crops up the next day. So you have to kind of know, you got to draw the line somewhere, but it's unfortunate. But we'll see. We'll see whether this thing whether I can do anything with this. I'm just going to pull that cap out, that C15, from the other side here, and see where that trace goes. I'm not going to change it or anything. I'm just going to pull it and see where the trace goes. And see whether this is the one that was leaking. Looks like it was. But where's that trace? Okay. Now we can see that the trace that's been eaten away by this cap, I might change this one cap, 330 at 10 volts, because this one obviously was puking. But now we can see where the trace went. The trace actually is these two traces here, and this one's gone. So this might in fact be the fault right there. That trace there is eaten away completely. There is nothing. And this one here as well. This other one looks like it goes under this cap and ends up right over here. So in theory, I could just take a piece of wire, stick it through the board, and tack it down over here somewhere. And same with this one. Or even follow this where it goes. But that one for sure is, this one here is also eaten away. You can see it. So maybe I'll try just fixing those two and see whether that will actually get this thing to work. And see this old cap, you can see this one's been leaking. You can see where it's been leaking from the negative terminal right there. For repairing the board, I'm just going to use this is Cat 3 wire without all the twists. This stuff is kind of useless for anything these days because it doesn't have a twist to it, but I have a whole box of it. Yeah, it goes right down here and comes over to this one. Right there. Right here, where'd it go? Right there, I can just bend it over and tack it down to the nearest pad. I believe that's the closest one. My magnifier so I can see what I'm doing. And yeah, that's the closest one. So we'll put that one through to there. And the other one, we'll just remove the solder from the board so that I can replace the caps that were leaking. So that's one trace that should be good. The other trace is this next one beside it, which is right here. I wonder where it goes. Let's see here if I can see where it heads off to. It goes way over here somewhere, so we'll try to grab it right in the same area. Notice what I'm doing here, right? I'm using the heat from the iron to actually melt the plastic so I don't have to strip it. I can just melt it a bit, put it in here, and it's got some tin on it now, and put it in here and just tack it down. and that should hold. And the same on the other side. I'll just put some heat on it to melt the plastic back. Like that. That way I can push it down through the board itself. This is going to go down through this hole here. I just put some heat on it, and then the heat will transfer through the wire and burn through the conductive paint, and allow the wire to go through. So it's right on this right there. It goes up to C7. Just scrape some of the insulation away off the board. I can find my little scraper, wherever my little scraper went. My little scraping screwdriver. There it is. Okay, I got the circuits prepared, I think. I'll try another, I'll put a couple of caps in there, new ones. For the two that were leaking. And we'll try this out. I don't know if these caps are going to work because they're not as low a profile, they might hit something. We have to bend them over, so I'll leave some extra leads on them just because the original ones were very low profile and these ones are not, so I may have to bend these over just so that they fit. So we'll just try these and see whether this thing will do any more than it was doing before. Now obviously this is not going to be a total rebuild on this thing. If this gets it working, it'll work for a while, but I wouldn't count on this being a long-term fix by any stretch of the imagination, just because of how old this thing is and all the other potential problems that are going to crop up on this thing going forward. So let's try turning on the power and see whether this thing will do anything more than it did before. Okay, power on. Will it go into play? Nope, still not going into play. So it's more than just those. Okay, all these caps are leaking. You can see it. Look at the electrolytic that's leaking out of the board, out of this cap. You can see it. It's wet. You can see the reflection on the board. You can see it. Look at the liquid here. They're all leaking. Every one of these caps. They've been sitting for years and years and years with no power applied to them. And the seals were all shot. And then what's happened is the first time the unit's been powered up, that's probably why it initially worked for him, and he got a black and white flashing in and out of sync picture. I was going in and out of tracking. Because they initially started to work, but all the seals on these capacitors have failed. Right, and what happens when the seals fail is the electrolytic gets forced out of it and it's attacking the board. So this one here is also definitely shot. This trace under here is also, you can see, it's been damaged. There's another trace over here that's damaged. Every one of these caps is going to have to be replaced in order to make this thing operational, and that is just not economical to do that. We got short circuits everywhere on this board, just from that electrolytic. Because the electrolyte that comes out of the cap will be conductive. Look at the trace. This trace is lifted right off. You can see it. See that? That trace is actually lifted right off the board. Yeah, unfortunately, this thing's toast. I give the guy an email and let him know that this thing is beyond repair. Unfortunately, it would have been a nice one to see if we could get it going, but there's just There's just too many things wrong with it. There's another one over here, another trace over here that's, where was it? Right down in, where did I see it? Right in here. See that one there? It's all green. Yeah, all these traces are shot. I might try to repair this one here and see whether that'll do anything, whether that'll make any difference. I don't think it's going to do a damn thing as far as this thing goes, as far as this thing operating. I think we're at a lost cause on this one. I'll try a couple more traces and see whether I can just get this thing to do anything more than it's currently doing, which is not even loading the tape. And I think that the reason for that is that there's a signal that's missing. It's not detecting that the drum is up to speed, or it's not detecting the capstan is up to speed, because the capstan servo also has to lock up. So if it doesn't lock up and give the correct speed, then the microcontroller will shut it down. And it just so happens that this circuit is the capstan. You can see it says capstan free run. These capacitors here are in the capstan circuit. So we'll just pull this one out here and see whether I can repair that trace and get anything happening. What am I pushing on there? That's this one, yep. That is this one. Yeah, you see? You see that? That one's been leaking. Something bad. C41. C41 and the one next to it, wherever that one was, C33. Those ones there are bad, and they've damaged this trace. This trace here, and I think this trace beside it has also been damaged. There's two traces here. One of them comes back. This one here, it's right there. I don't know if you guys can see it, but that one there, and it traces back along this way. And it looks like it ends up back over here. Oh, that looks like that's going to the same trace. That looks like that's the same one that I repaired on the other side. It is. It is the same one. What about the other one? The other one's right next to it. Yeah, this is the same trace. And it's missing. If I put my meter on there, you'll see it'll beep. So that looks to be, is it this one or this one? This one here. You see, that's that trace there, and that's supposed to go up to here. Oh, that was good. That one's through. Okay, that one's not burned up. But this next one to it, this one comes down here, and it goes through to. Trying to see where it goes. It comes up here, I think. Goes around there, comes up here. Okay, it's open. Looks like it's open right there. It's not going through to here, that's for sure. That trace is open. There, it's good there. Good. And does it come up to here? Open there. So it's good right to here, but it's open right in here. Yeah, that one's open right along in here. You see what I'm scraping? Nothing? If I go back here a bit, I've got continuity back here a bit further back. Where was it? Right there. I got continuity there, but I don't have continuity up here. Yeah, nothing there. So I'll put a new C41 in. This is the capstan servo circuit. And we'll see whether we get any different results. Nope, still the same. Okay, I think I'm getting somewhere on this thing. Let's just say, if I can get this thing fixed, it's going to be a very expensive repair. There's a break in the board right here. See the crack? This thing's been bounced when it was shipped. That would explain why my symptom is different than his. His symptom was, he said, it played without color. But I don't even get it to load up. That would explain why. There's a break in the board here. The playing without color sounds like a servo problem. That would have been the capacitors and the other traces that have been eaten away, but the fact that it's not even loading up, well, this is probably where this is, right here. I bet you there's more than one break in this thing too. See if I can repair this and see if I can get anything else happening other than what it's doing. It would be interesting to see if this thing works. If I get it working, will it survive the transport back? It's a problem when you have something heavy like this, is you get these morons that work at the post office that just throw things around. And this is fragile. These are fragile circuit boards on here. The biggest problem with these portable VCRs when they were current was broken boards due to people dropping them. Because a portable VCR was something that got dropped on a fairly regular basis, just because they were heavy, and people were carrying them around with their camcorder and dealing with their kids and stuff at Disneyland, wherever they had them. And yeah, they got dropped a lot. I used to see a lot of broken circuit boards on these type of machines. So I was very glad when the camcorders came out. I never had to see another one of those pieces of crap again, because a lot of them were in sad shape or beyond repair. That's how I got my SL2000, was somebody had it, damaged it, and they traded it in on a camcorder, and I took it and fixed it and used it myself for a while.
Yeah, people working from home, doing their sales deal while walking up and down the street, talking so loud that all the neighbors can hear everything they're saying.
Let's just see whether that will change the way that this thing operates compared to how it's been operating. Power on. Oh, there's some brakes on the top side too. Damn. I persevered and found one more by measuring this trace here. It was open. So I put a jumper wire on this one. I fixed the circuit board on the other side over here where it's damaged. I've spent far too much time on this thing already today. I've been working on this thing now for about 3 hours, and I'm ready to call it a day. One last try. It's not shutting down. Let's see if we get a picture. Hook up the monitor to this thing. I don't have the audio head plugged in, so there won't be any sound, but is there a picture off this thing? Kind of have a picture. Let's plug the audio control head in and see whether we'll get anything happening that we weren't before. Ooh, what happened there? I don't think there's any sound on this thing, but maybe there is. I don't hear any sound. When I touch the board, I do. Let's just rewind this tape. We'll try this tape from the beginning. See if I can get anything to play back on this tape now at all. I think I got this thing back to how it was when this is how he described it. He said it played, but there was no color. To say I spent hours just getting this thing back to where it was. Broken circuit board and several traces that were bad. So now I'll see if I can get this thing to actually play. I'm just adjusting the drum free speed, by the way. And get it to clock in. Okay, now the cap's in free speed. Okay, so I got the caps in free speed locked in. How's tracking working? Tracking is actually doing something now. Okay, now, no color yet. I don't know if I'm going to be able to get the color working on this, but let's try. Color circuit is a totally different board. Let's go. I'll change tapes first of all. I don't think there's much color in that portion of the tape, so let me put something else on. Our servo's not locking in. I'm going to put it in pause so I can get the free speed for the cylinder set. It's hunting. I might have better luck putting this on an analog monitor rather than a digital one. Here's where I am at this point. Going to play. I get a nice solid black and white picture. Sound needs to be improved. The record play relay probably needs to be cleaned. Don't have any color yet. Now he's going to work on the color. We went from having nothing to having a good, solid black and white picture. So I'm on the right track. It's just a matter of finding out why we're not getting any color. Just trying a few off the level adjustments here. Just to see whether we're just off a bit. Okay, I'm getting somewhere. I've got some color. Got my sound, well, sort of. Had some color there momentarily. Okay, got some color. quite good. This is the automatic frequency control, and the color oscillator, and then the auto phase control, trimmers. I have color. Now it's not perfect color yet, but it's better than I had a few minutes ago. Oh, it's looking a little better. Well, part of the problem is the bloody plasma, when it's turned on, throws out so much noise that it messes everything up. But on an analog TV, it's actually not looking bad. Those are the right colors, right? This is an HD color bar generator, so you have the extra 2 gray bars. But the HD generator, which I use to generate this, is has got the extra 2 color bars along with this the stair-step sweep. Oh well, I can play this Bose commercial. I can't find my other color bar tape. It's around here somewhere. We'll try this other tape. For the blue light XIF, which I think I've mentioned before. This was one that I shot many years ago, like 15, 20 years ago, somewhere in there. Bit of a time base error on this tape, isn't there?
The deadly outbreaks brought on by these microorganisms have created a greater awareness of the air quality inside our homes and the germs and viruses we all breathe every day.
Tracking control. Let's see if the tracking control works. Yes, it does.
Miracle Man is proud to present the blue light ultraviolet extra intelligent filter, the XIF.
Okay, that's working. And I think at this point of the game, I'm going to call this a success, because I had something that wasn't working when I started, and now it plays back with minimal parts. I put 3 capacitors, and I repaired 4 copper traces that had been eaten through, and 4 traces that were damaged due to the circuit board being broken. Okay, it's playing back my Stevie Ray Vaughan tape, no problem. I'm going to try making a recording on this thing and see how it records color bars. So I'm just recording some color bars at the end of this tape. Note the little Hall effect sensor here, detecting the rotation of the magnet on the tape counter. That's so that if the take-up spool were to stop turning, it would go into an emergency shutdown. I was going to record some color bars from my camera here for a couple minutes, and we'll see how the color bars play back. And if the color bars play okay, I'm going to button this thing up, because I don't think there's much else I need to do to it. I'm not testing the recording for sound because I don't have a mini plug adapter, but we'll see how it records color bars. And if it's recording color bars and it's playing sound and playing color, then I think we're probably in a pretty good shape. I put some contact cleaner into this relay down here. This is the record play relay for the audio, so I cleaned the contacts on that. Okay, that's the tape at the end. Let's rewind it and see what it does. Looks like my drum speed is maybe off just slightly. I'll have to double check my free run for the drum on record. Okay, now I've got perfect black and white bars. I just adjusted the record shift switch point slightly. So we're gonna just try adjusting the one of the color circuits. Where is it here? One of the chroma settings. Playback chroma. There should be a record chroma on here. I'm just looking at the board here for record chroma. See if we can tweak that. I would normally use a scope for this, but I don't have a manual, so I don't know where to connect the scope, and I don't know what my settings should be because I don't have a manual for this. So I'm kind of having to eyeball it, because without the actual service manual, I don't have a clue where to connect the scope to. And even if I connect the scope to something, I don't know what I'm looking at unless I have a manual to give me a reference. This control here is the record chroma. So I'm going to try just tweaking that ever so slightly while making another test recording here. Just rewind my tape a bit. Throw it back into record. And just try adjusting this chroma control ever so slightly. So I'm just going to rock it back and forth ever so slightly just to see whether I get any difference on playback. I'm convinced that I'm still looking at a trace problem. There's another trace down here that's kind of green. There's a capacitor down here that's also looks like it's leaking. This is in the color circuit, this area here. This is the chroma circuit. And I don't know whether, like, I don't want to is that a hole in top of that capacitor? Almost looks like it, doesn't it? I think it's just dirt. Yeah, it's just dirt. But I don't want to tweak any of these controls any more than I have to, because I don't have a manual for it. So getting everything set up properly is going to be tough without knowing what frequencies I'm looking for and what test points they're supposed to be on. I have to assume that unless somebody monkeyed with them, which is entirely possible because I don't know the history of the unit, but just judging from what I've found so far with the traces being corroded, I think that's probably where we are. I'm just going to pull this little cap here out and take a look underneath it. It's all green around here, so you can see it. There's a through hole connector here that goes under this delay line and goes God knows where. But it's becoming a real tough one because I can't see where a lot of these traces go because they go under other components. Somewhere in here, though, there's a problem in the record signal. It's not making it through. Playing back is fine, so it is picking up the converted color that's converted down to 629 kilohertz, and it is up converting it back to the 3.58 megahertz, or 3.579545 to be exact. So we know that the color conversion circuit is working. It's just not converting the color down to 629 to make the recording, which could be a problem in the color circuit, or it could be a problem in the record circuit if it's not recording that 629 bandpass signal. So there's the cap out, and you can see this trace here it's been damaged. It's green. I don't know if it's open, but it certainly is green, and this cap here certainly has signs that it's been spewing its guts. So if we test this one, and this is what I've been doing all day, I've been testing these traces from one end to the other. That one's measuring good, but definitely has corrosion on it. This cap is definitely shot. It's a 10 mic at 16. We'll try a new one of these. You guys are wondering why this video doesn't seem to be all as long as you would think it should be. I've been working on this thing now for 6 hours, and I'm ready to throw the towel in on it because for what I'm going to make fixing this thing here, I've basically wasted an entire day where I could have gone through and fixed a couple of stereos that were sitting here waiting to be fixed. But I didn't realize that this was going to be such an involved job when I got into it, or I probably wouldn't have got into it. It's definitely being a lot more work than I had really ever imagined that it would be. We'll try it again and see whether we get any color. Well, there's playback of my pre-recorded color bar tape on the plasma. It's actually playing on the plasma properly now. I talked to the guy that owns it, and I think we've come to the same agreement that this unit, as much as he likes it, it's not worth spending a lot of money on. And to get this thing properly functional, I think would require spending a substantial amount of money, because I'm convinced that the problem is failing electrolytic capacitors. I've changed 4 of them to get it to this state, but it's not recording chroma properly, and to get the chroma going, I think would require changing the rest of them. I mean, even the other ones they're 40 years old, and this was around the time that the capacitor problems started to appear. Early 80s was when we started to see a lot of capacitors starting to show their age, let's say. This thing's going to be close to 40 years old. I don't know the exact year that this one was made, but I would guess it was probably 81. 1980, 1981, maybe. I don't even think it would be 82, because this is a single speed deck. And looking at the chassis on this one, the chassis looks to be the same aluminum die-cast belt drive chassis that Panasonic used in the early 80s, like the very early 80s. It's it's old. It's very old, and it's not worth spending a lot of money on. And to get this thing back up and running could cost a couple $100 in time. I mean, I've already spent the better part of the day getting this thing to the state that it is, and the guy that owns it just said, well, if you can't get the color going, you might as well just keep it or recycle it, which is, I think, what I'll do, is maybe just put it away and hang on to it for if I need a part off the thing, and leave it at that, because, to say, it's not worth spending a small fortune on something like this. Anything that gets done to this is going to be a short-term fix, unless all these electrolytics are replaced, because there's lots of areas on the board where they are spilling their guts. This one here was actually, this one down here was actually leaking today. I changed it. The one that was here was actually leaking when I powered it up. And that's the problem. When you get these old caps like this that have been sitting around for eons without being used, you power them up and they start to leak. So I think the right decision was made on this. I wish I could get it going fully to record color and play color and everything, but as it sits, it's able to play tapes, and it actually looks pretty good. I think that's about all we can expect out of a machine of this age at this time, without spending a small fortune to fix it. So with that, I'm going to close this one up. I mean, you can see all the work I had to do just to get it to this state. There was a break in the circuit board here, and the traces on the top that were bad. Yeah, it's wasn't in great shape. It wasn't in great shape when it arrived. I think they probably bounced this thing when in shipping, and that's how the board got snapped right here. This thing got bounced when it was on its way. But yep, we'll put it back together, and I'll give it a last test run before closing off the video. See, the way these things were all put together like this, I'm surprised that they even worked at all, to tell you the truth. A lot of boards on these. And looking at the design of this thing, looking at the layout of this thing, this looks exactly like the same chassis that my 1979 VHS machine. It was a Panasonic made for RCA. It was a VCT201. This looks like exactly the same chassis as that. It was an aluminum chassis with a steel plate with the guides on it. So I'm looking to see if there's a date code on this thing so I can see when it was made. Okay, 81. There is a date code on this. So it was 1981. Here it is here, 24th of June, 1981. That's when this motor was made. So I was right. I figured it was 81. Because they ran this chassis for a couple of years and then they upgraded to the next generation of chassis. So that puts this thing, 39 years. And they didn't make these things, as I say, very long because camcorders came out shortly after this. Sony had their first camcorder out in, what was it, 83? The beta movie? I think it was 83. Because the 8mm came out like the next year, 84. Either 84 or 85, the 8mm format came out. But yeah, the Portapak units weren't around that long because nobody liked carrying these things. They were too bloody heavy and big and bulky, having to carry a separate camera. Anyway, it's built like a brick shipyard, and that's part of their downfall was the weight. It's you get bumped around a bit and the circuit boards break. So I'm just putting this thing back together. Put the shield back on here over the head. I love this. The warning. So this unit now is, we'll test it again now that I put it all back together, see if it actually still even turns on. But this unit now is going to go out into my collection of old junk in my storage unit, and it'll be sitting right next to my SLO 340, which is the Sony Beta 1 portable. That's even bigger than this thing, by far. It's quite a bit bigger and heavier than this one. And it did work the last time I tried it. This one's playing back color bars again. As they say, they're noisy, right? It needs all the caps changed on it. Playing it back, but if we compare it to what the color bars coming off the camera look like, that's what color bars should look like. And I'll just, for the hell of it, we'll put this other tape back in and just hit record one final time. And see if it still records a black and white picture. I don't recall it making that noise. There it is, you see. I don't recall it making that drum noise when it was sitting apart. but then it wasn't sitting with the weight on the drum. You can hear the drum making noise there. So it wasn't sitting with the weight on it, it was sitting horizontal. So maybe the bearing's starting to go a bit bad onto it. Anyway, it's back together. It's going into storage. Be used for picking parts off, I guess. Thanks for watching.